Okay, and this is the last video in Unit 1.1 for the Paper 3 HL section of the course, okay, and it's market equilibrium, all right? So again, just getting into a number of the questions. Now, we have seen this question a few times before, but again, never any harm to make sure that we go over things so that we're absolutely 100% confident in our understanding of how to do things, okay? So it says, note that widgets are an imaginary product. In country X, the supply and demand for widgets are given by the functions the quantity supplied equals minus 45 plus 4.5p, and the quantity demanded equals 180 minus 3p, where p is the price per widget in dollars, qs the quantity supplied of widgets, thousands per year, and qd is the quantity of widgets demanded, thousands per year. Okay, nothing crazy there. Then we have a demand, or the diagram, excuse me, for those functions, and we see that the demand curve is downward sloping and the supply curve is upward sloping here. And the reasons for this, which is kind of coming to now in a second, okay, just keep an eye on each of those functions, all right? So it says identify the slope of the supply curve. Well, what we've been saying before is that the slope equals the number before the price, before the p. And the supply function is given by minus 45 plus 4.5p. And I keep on mentioning this point, okay? It's not just 4.5, that's not just the slope, it's also the sign before that. Because as we can see, the supply curve is upward sloping. And what we're saying here is that this plus means that it is upward sloping. If we look back here, just to give a quick kind of idea about what these things here are, we see that the number before p for the demand curve is minus 3. And what that actually means is, and I'll go through all of this kind of stuff now in a second, but what that actually means is the minus 3, if price increases by 1 unit, let's say $1, the quantity demanded will fall by 3. That's what that means. For the supply curve, if price increases by $1, the quantity supplied will increase by 4.5 units. Now, how you get a half a unit, I don't know, but if we're talking about kilograms, that does make sense. Okay, so that's the first thing. The slope is the number before P. Now, the next thing here says, outline the reason why quantity supplied increases as price rises. Well, we've said this in previous videos, but I'll happily quickly go through it here. At a higher price, the profit margin per good sold is greater. Therefore, there's an incentive to produce and offer more goods for sale. That's one reason. That's enough to get the 2 marks. Another reason that you could give to get the 2 marks again is that don't forget that the supply is the marginal cost to the firm. So since marginal costs rise at higher levels of output, a firm will only be willing to offer more units for sale per period at a higher price, okay? More on that in previous videos, but I think if you understand the general theory regarding demand and supply and all this kind of stuff, that really should make sense. Okay, now there's a few things that I want to go slightly deeper into here, okay? But before we do that, I suppose I'll just quickly answer this question. So again, in previous videos, we've answered this question. So it says, an increase in cost of production has resulted in a new supply function, QS equals minus 60 plus 3P. Draw and label the new supply curve in figure 1, which is the previous figure. So in order to do that, we need 2 points, because these are all linear, and we can see that there's no squareds here, so it's going to be a linear, a straight line supply curve, okay? Well, the first thing to draw it, I would argue, is to write down the function. Now, a great way whenever you're doing supply or demand for that matter is you can set quantity equal to 0, okay? So if I set quantity supplied, okay, and I'm going to write set quantity supplied equal to 0. So instead of quantity supplied, I've got 0 minus 60 plus 3p. Then what I'm going to do is bring the minus 60 over, that becomes a plus, and then 60 equals 3p. I'm going to divide both sides by the number before the letter I'm trying to find. 3p divided by 3 is just simply 1p or p, and then 60 divided by 3 is 20. So I have 20 equals p. So what I tend to do is just I'm a creature of habit, right? P equals 20, quantity supplied equals 0. So what I'm actually going to do now is I'm going to go back to the diagram and I'm going to say, okay, look at a price of, at a price of 20, quantity supplied equals 0. Well, this is this point here. Okay, so that's the first point. Now I need, another point. So what I'm going to do is, and I've used different numbers in each of the, I think in all the videos that I've answered this question. And the reason is just to show you that there is a million different ways to answer this. So what I would do is, and what I've chosen here is, I'm looking for something a price that would be up a little bit higher. Now, you never want to go all the way to the top, but something higher so that I can have a bit of a distance between this point and wherever the next point is. Okay, so hopefully that will help me draw a clearer and more accurate line. Okay, so what I'm going to do here now is I'm going to set price equal to 60, and all that the function does is that it tells you the quantity demanded, or quantity supplied, excuse me, for any given price. So if I put in price of 60, it'll tell me the quantity that will be supplied at that price. So instead of P, I'm going to put 60 here. So the quantity supplied equals minus 60 plus 180, and if I am correct, and I believe I am, 180 minus 60 equals 120. So at a price of 60, the quantity supplied equals 120. So what do I do then? Well, I go back to my, at a price of 60, and it's 120. So here's 120, and I go to this point here. Okay, and that's the two dots. That's but it's like there's. I could have chosen a number of different dots or a number of different price, quantity, supplied combinations, right? But that's that one. Now, this is S1 because here it says QS1, okay? Now, what I want you to see here is, don't forget, there's a few things. I'm going to kind of be, I suppose, looking at it like this, okay? So for the original QS, it was minus 45 plus 4.5p, okay? Here, it's minus 60 plus 3p. Okay, so the first thing is that the supply curve is shifted upwards because it was minus 45, now it's lower. And I know you're like, oh, it's lower, it should have shifted down. No, it's shifted upwards, meaning that there will be less supplied at every given price. Because this number here on QS1 here is lower, that I know it's kind of counterintuitive, but that means that there's going to be less supplied at every given price. Okay, and that represents itself as an upward shift. But as you should also be able to see, the slope is different. And why is the slope different? Well, look at this here. This was 4.5 and now it's 3. So what you should kind of notice from this is the 4.5 one and this is the 3 one. And as the number gets bigger before the P, the slope of the curve, no matter whether it's demand or supply, this is obviously supply because they're both pluses and we're told in the question, but the curve itself will get flatter. As the number gets smaller, this is the 3p, it gets bigger, it gets steeper and steeper. Okay, so I just wanted to make those points there just to give you a greater understanding of exactly what we're doing. Okay, so we've answered that question. Excellent. Okay, now the next thing here is this. Okay, using your answer to part C, outline the reason why an increase in cost of production has resulted in a new supply function. Right, so an increase in the cost of production will reduce the profitability to the firm. Okay, what we're saying is that will reduce the profit margin, or the amount of profit, the percentage of profit per good sold, causing producers to be less willing to supply the good at each price. And the reason is because if you want more of something, there has to be a greater reward for the person that's producing it. So the fact now that the profit margin is lower, well, that means the reward is less, okay, and as such we're going to get less of it. Okay, this means an inward shift in the supply curve. You can say inward. I like to say inward because it's shifted from there inwards. You can say upward shift. It's all the same. It doesn't really matter. Okay, now I have to refer back to this diagram here, so that's exactly what I'm going to do. Okay, so in this question it says calculate the change in producer surplus resulting from the increase in cost of production. So I'm going to go the old one first. Now, what is producer surplus? And actually we come to that. It's the difference between what the amount of money that the supplier received for selling the good, right, which is the selling price, and what they would have been willing to sell the good for. Okay, so what graphically what we need to do is we need to find the original selling price. And what we can do here is just go from the equilibrium point where the original supply curve crossed the demand curve, and the demand curve hasn't changed here. And then we need to find the quantity. And I believe that's 90,000. And I'm right. I'm confident that I'm right to believe that. Okay. So what we need to say is that this here, this triangle here between 30, 10, and 90 is the producer surplus that originally existed. Okay. So we need to find the area of this triangle. Well, how do you find the area of a triangle? Well, it's half the base times the perpendicular height. So this I'm going to say is the base. So I need to find the difference between 30 and 10 and half it. And then I'm going to say the quantity, the equilibrium quantity, is the height of the triangle. Okay, so what we're going to do is Just keep that there, realize that. So this is where I'm getting the numbers from. The base is 30 minus 10 and the height is 90. Okay, so what we're saying is the old producer surplus was a half times the base, which is 30 minus 10, times the equilibrium quantity, which is 90,000. And don't forget that these numbers are in currency. They're measured in currency, in this case dollars. Okay, so it's a half 20, or excuse me, I'm getting ahead of myself. 30 minus 10 is 20 times 90, 90,000. Okay, so a half times 20 is 10 times 90,000. And then 10 times 90 is $900,000. Okay, now the next thing we have to do is say, okay, well, what's the new level of producer surplus? And again, it's the difference between the selling price, so we get that from the equilibrium, which is here where the new curve crosses, and what they would be willing to receive, what they were willing to sell the good for. Okay, so they were always willing to sell it for less, because if they were only willing to sell it for more, it wouldn't have been sold. All right, so now what we have to say is, well, it's the base, half the base times the height. Well, the height here is 60,000. I'm using the quantity here to measure the height. And the base is 40 minus 20. Okay, so we go back over here and I go like this. Just making sure you can see, and you can. Okay, so 0.5 times 40 minus 20 times 60,000. Where did I get each of these numbers? Okay, here's the base, so it's 40 minus 20. It's got to be half that because that's a triangle, and then the height is 60,000. Okay, so it's a half 0.5 times 20 times 60, 1, 2, 3. Okay, so a half times 20 is 10 times 60,000, which is 600,000. Excuse me, $600,000. Okay, now so that means then, if this 600,000 is the new producer surplus and the 900,000 is the old producer surplus, well then to get the change we just have to take one from the other. So the change in producer surplus equals 600,000, and I will put in the dollars just to remind myself, minus 900,000. So the change, therefore, in producer surplus equals minus. The producers are worse off now, and of course they are, because their cost of production has increased. An increase in the cost of production certainly doesn't make a producer better off. Okay, so I would hope that would make sense, at least logically, and it's always important to understand the logic behind anything that you're doing. So it was minus 300,000. Okay, now on to another question. Right, and I'm going to need some spare paper here, I think, and I have some here. Excellent. Okay, so what we're going to say is, I'm just going to start off on this page. So, widgets and pidgets are imaginary products. In the country of Berbia, the demand supply for widgets are given by the functions. The quantity demanded equals 249 minus 4p. The quantity supplied equals 150 plus 14p. Where quantity demanded is the quantity demanded per month, quantity supplied is the quantity supplied per month, and p is the price per widget in terms of dollars. Now, the first thing that we have to know here is calculate the equilibrium price and quantity per month. So what equilibrium? Okay, where does it occur? Where QD equals QS. Okay, it's where QD equals QS, right? So what I'm going to do now is just looking up here, QD equals 249 minus 4p, and QS equals 150 plus 14. So I'm going to go slightly onto a bit of rough work here and just rewrite these things. So QD equals 249 minus 4p, and I've got QS equals 150 plus 14p. Okay, so now what I've got to do is set QD equal to QS, and that's what equilibrium is. And when I do that, I can solve. So I've got 249 minus 4p equals 150 plus 14p. Okay, so I'm going to bring this 4p over because I like to deal with positives, and I bring this 150 over, and then I have all numbers on one side. Bring it over, change its sign. and all letters on the other side, bring this over, change its sign. So 249 minus 150, I believe that's 99, and 14p plus 18p, and I believe that's 18p. Okay, so like always in the previous videos, you divide both sides by the number before the letter you're trying to find. We'll get the calculator out here. We'll go 99 divided by, so you can see it, 18 equals, and I get 11 over 2, which is 5.5. Okay, so we have 5.5 equals P. Now, just to be clear, that's not the question answered, because it says calculate the equilibrium price and quantity per month. Okay, so what we have an equilibrium price of 5.5, $5.50. That means that if I put that in, that means at a price of $5.50, quantity demanded will equal quantity supplied. So to be honest with you, it actually doesn't matter what function you put it into, whether it be the demand function or the supply function. Just to be clear, I'm just going to show you, I'm going to prove it to you. Well, it's not technically a proof, but I'm going to show you that it doesn't matter which function you put it into. So quantity demanded equals 249 minus, and I believe I'm just going to do this anyway, but by 4 equals 22, and I am right. Okay, 22, and I'm going to do all of this calculation on the 249 minus answer equals, and I get 227. Okay, so 249 minus that equals 227. That's the quantity demanded at a price of 5.5. If this is truly the equilibrium price, well then the quantity supplied should be the exact same. So we have QS equals 150 plus 14, and instead of P, I'm going to write 5.5. Okay, so QS equals 150 plus, and then I'm going to go 14 times 5.5 equals, and I get 77. Okay, plus 77. So QS equals 77 plus 150, and I get 227. And as we can see, that is correct. They're the exact same. So the price is $550 and the quantity is 227. And is that in any kind of dollars per widget, quantity demanded per month? It's not in kilograms or anything. So price equals $5.50 and the quantity equilibrium, and I might as well write EQ equals 227 units. Okay, 227 units. Okay, excellent. Now the next one here is calculate the excess demand or excess supply and state which of these it is at a price of $8.50. Now you need to think, okay, the law of demand says people buy less as the price rises, and the law of supply says firms produce more as the price increases. Right, so this here is higher than the equilibrium price. All right, so supply is going to increase and demand is going to fall. So straight away you should be using your intuition. This is not like how to answer it, but straight away you should use your intuition to realize that because this price is above the equilibrium price, quantity supply is going to be greater than quantity demanded. Okay, so what we're going to do now is I'm going to go back to this here. I'm going to rewrite QD equals 249 minus 4P, and then I'm going to write down QS equals 150 plus 14p, and then what's the price here? The price equals $8.50. Okay, $8.50. Okay, now so let's go at QD. Okay, we have 249 minus 4 times 850. So QD equals 249 minus, and I'm going to go 4 times 8.5 equals, and I get 34. Okay, excellent. Minus 34. Okay, and I get QD equals, and I'll go 249 minus answer equals, and I get 215. Okay, equals 215. Okay, excellent. Now I'm going to do the quantity supplied here. I'm going to go QS equals 150 plus 14 times 850. Okay, QS equals 150. Now I'm going to go 14 times 8.5, and I get an answer of 119 plus 119. QS equals, and I'm going to add 150 to that, and I get 269. Okay, so I get QS equals 269, which is simply just the addition of 150 and 119. Okay, now let's have a look at this. Okay, so what I'm going to say is the excess, So where quantity supplied is greater than quantity demanded. Now it is. So what we're going to say is that quantity supplied is 269, and I'm going to take away the quantity demanded, which is 215. So I get 269 minus, just making sure you can see that, 215, and I get an excess of 54. Okay, so it's 54. So I write down here, okay, I've done all of, you'll see that I've done all the workings out. So I get excess supply, 54 units. Okay, now the next question, the next question, you may feel that it's somewhat difficult, somewhat unusual, somewhat whatever, and the answer, unfortunately, you may also feel that it's a little bit of a tricky one too. Okay, forgive me, I'll just move this camera down so we can see the paper easier. Okay, so what I'm going to do is going to flip this over and then I can use this page. Okay, so what we're saying is calculate the price at which excess demand of 18 widgets would result. So the mistake that a lot of people make is they add on 18 onto the demand function, which is here. Okay, now you don't want to do that. Okay, the reason is you want more to be demanded than supplied. So what you have to understand is if we got an equilibrium price of 550, the price has got to be lower than that. Okay, now if you add on 18 to the demand function, you're actually going to get a higher price. It's essentially an outward shift in the demand curve, and that won't work at all. Okay, so the counterintuitive thing you need to do is you need to take 18 away from the demand function, and then you find the price. And the reason is because we want demand to be greater than supply. Quantity demanded be 18 units greater than quantity supplied. So if we find the price where minus a quantity demanded of less than 18 is equal to quantity supplied, that will give us the price where the demand is in excess, the quantity demanded is in excess. Okay, so just keep this in mind. These are the things that, but I'm going to be messing with this. I'm going to take 18 away from the quantity demanded, okay, because we want an excess demand. And again, you must forgive me here, guys, I'm just moving the camera, because we want it's quantity demanded minus 18 equals quantity supplied, and that will give us excess QD of 18 units. Okay, and again, the reason is if we find the equilibrium price where the function has been reduced by 18, then that will mean that there's going to be 18 more demanded than supplied. Okay, now again, I'm just reading off this sheet here, so I don't want to continue, trust me on this. Okay, so QD equals 249 minus 4p. Okay, so QD minus 18 equals 249 minus 4p minus 18. Okay, and that's 249 minus 18 minus 4p. Okay, and then what we're saying is, and I get this out again, now I'm confident enough, was at 231, I'm not taking the chance, 249 minus 18 equals 231, fantastic. Okay, so then what we have is 231 minus 4p. All right, now what we've got to do is, we've got to set this function equal to the supply function, okay, and the quantity supplied function equals, I'm just reading it off the sheet, 150 plus 14p. Okay, so what we've got now is 231 minus 4p equals 150 plus 14p. So 231 minus 150, I'm going to take this over, change its sign, equals 14p. Take this over, change its sign, plus 4p. Okay, so 231 minus 150, and what I get there is 81. Okay, so this is 81 equals 14p plus 4p is 18p. So as always, divide both sides by the number before the letter you're trying to find, and I get here, I go 81 divided by 18, and what I get there is that equals 4.5. Okay, so I have 4.5. Remembering, what are we dealing with here? Dollars. So calculate the price at which excess supply, just making sure you can see, excess supply is 18, or excess demand, excuse me, is 18 widgets, and then the price is $4.50. Now let's check this again just to be sure. I'm sure you trust me and all that, but like there's no harm in checking everything, okay? Amazing stuff, just making sure. Right, so the quantity demanded, the original function is 249 minus 4p. Okay, so that's 249 minus 4 times 4.5. That's 249, and 4 times 4.5, I believe, is 18. And it absolutely is. Okay, 18. And then equals. The quantity demanded at a price of that is 249 minus answer equals 231. Okay, now that's 231. Now the quantity supplied, the original is 150 plus 14p. 150 plus 14p, which is, well, I'll write down p here, why not? So equals 150 plus 14 times 4.5, which equals 150 plus, and then I'm going to go 14 times 4.5, and I get that equal to 63. Which and then I add, so I have to add these two together. So then I just add 150, and that equals 213. Okay, so that equals 213. So if I then go 231 minus 213, okay, so I just go 231 minus answer equals, and I hope you can see, and I believe you can, that's 18. So demand is greater than supply by 18 units at a price of 450. Okay, excellent stuff. All right, now we're back to a few more theory questions. Okay, a demand curve is drawn under the assumption of ceteris paribus. Using an example, outline why the assumption of ceteris paribus is necessary when analyzing the effect of a change in price on quantity demanded of a product. Why do we make sure that nothing else changes? Ceteris paribus, all other things remain equal. And the reason is, okay, so this means that a change in any of the non-price determinants. Now, I do say income or taste and preferences here. So if your income rises and the price rises, but price rises by 10%, your income rises by 1,000%. Why not? You're going to buy more of that good. The price is increased, but the amount that's bought has also increased. So then if we allow two things to change at once, we can't isolate the effect that a change in one variable has on quantity demanded, i.e. change in the price. So we have to make sure that every single other variable stays the same in order to analyze the effect that a price change would have on quantity demanded. And that's all we're saying here. So I'll read this out. This means that a change in any of the non-price determinants of demand, such as a change in income or a change in taste and preferences, may distort the effect of a change in price, meaning that the impact of a change in price alone cannot be determined unless all other factors are not changing. I really, really hope that makes sense. And again, we've done this in another video as well. Two products are in competitive supply. That essentially means that the inputs used for producing one are also used in producing the other. Using an example, outline how the supply for one of them is likely to be affected by an increase in the price of the other. So the answer is an increase in the price of one good, like wheat, let's say, will cause a decrease in the supply of the other good, example, barley, as the two products compete for the same resources needed to grow them. Essentially what we are saying here is that the relative profit of growing wheat has increased compared to the relative profit of growing barley, and as such you're going to devote more of those resources that could be used to produce both of them. You're going to devote more of those to producing wheat instead of producing barley. Right, now this is kind of one of the exceptions to the law of supply here, okay, saying that as price increases, the quantity supplied increases. And that's not true, at least in the short run, for certain things like what we're about to talk about. It just says that the capacity of a stadium for the final is 80,000, okay? So just draw the supply curve, right? That's all it says here, okay? Draw the supply curve for the World Cup final. All right, well, if it's 80,000, and I've explained this in the supply video, well then it's got to be what's called perfectly inelastic, or just a vertical supply curve on 80,000. And the reason is that the day of the game, if there is a huge increase in demand and the price is being driven up, which it can't really, because it can be driven up by touts outside buying tickets in order to sell them on further, but it can't, like, I mean, the price of these things are agreed months or years in advance. But still, if the price was going up, they cannot, like, immediately add more seats to the stadium. It's a fixed amount, okay? So that's why it's a perfectly vertical. So whatever the price is, there will be 80,000 seats offered for sale to the final. And, I mean, essentially, that's the end of that, okay? Now, I did this in a previous video as well, I believe, and all I'm going to do now is just do it slightly differently, again, to show you different ways to do it. So the first, the only question that it says, calculate social surplus at the equilibrium market price. Okay, the equilibrium market price is 6. Okay, you can split it up into consumer surplus, which I'm not going to do now, but consumer surplus is the area below the demand curve and above the price. Okay, and then you can also split it up into consumer surplus plus producer surplus, which is the area above the supply curve and below the price. Okay, so I'm not going to do that because I know that total surplus or community surplus or social surplus is just the addition of those two. So basically what I'm trying to do here is find the area of this triangle. Now, one thing, however, I will do, and I'll just use my black pen for this, keep like with like, that's the equilibrium quantity, okay? And that's 8,000 kilograms. Okay, so what we're saying here is we need to find the area of this triangle. So the area of the triangle is always half the base times the height. This is the base, which is 14 minus 2. 14 minus 2. And this is the height, which is 8,000, which is 3 kilograms. Okay, so it's a half. 14 minus 2 is 12 times 8,000. Half of 12 is 6 times 8,000. Okay, and then 6/8 are 48,000 what? Dollars. Community surplus is always measured in dollars. Producer surplus, oh, excuse me, you couldn't see all that. I do apologize, so I'll just show you this here. Okay, community surplus is always measured in currency. Okay, whatever that currency is, be it euros, dollars, whatever. Okay, no problem there, I hope. Now, that's the end of that. Okay, on to the next question. Now, what we're saying here is, in Ruritania, the demand for butter is given by the function QD equals 420 minus 19p, okay? Where QD is the quantity of butter demanded per year in millions of kilograms, okay? And P is the price of butter in dollars per kilogram. Calculate the quantity of butter demanded per year when the price is per kilogram is 7. Couldn't be easier, okay? Couldn't be easier. QD equals 420 minus 19p. I'm just going to write down P equals $7. Okay, so all we have to do here is substitute in 7 for price. That's all we have to do. Simple as. Okay, so QD equals 420. 19 minus 7 is 133, and then 420 QD 420 minus 133 is 287. Now again, lads, what? 287 million kilograms. Okay, that's what it is. Okay, don't forget that. All right, now on to the next question. And again, simple as, couldn't be easier. Okay, so QD equals 420 minus 19p. Okay, just got that from the question, no stress. And it says calculate when price is $10. Okay, so put in 10 here. So quantity demanded equals 420 minus 19. Instead of price, we put in 10. So that allows us to calculate quantity demanded. That's what the function does. QD equals 420 minus 190. QD equals, what's that? 230 million kilograms. Okay. Now, what I want you to see here is that at a higher price, quantity demanded is lower. That's the law of demand. I really hope that makes sense to you. Okay. But there shouldn't be, I would hope that there shouldn't be any difficulty in that question. Now, however, for this question, there should be plenty of difficulty because it really shouldn't be in this worksheet, but I've just done it anyway, just to kind of introduce you to something. Okay, so there's this thing called price elasticity of demand. I'm not going to spend too much time on it. Okay, because it's probably best to wait until the next section when we actually cover it. But it's never any harm to introduce you to something before we actually do it. Okay, so it says, explain why for a linear demand curve, the price elasticity of demand is not represented by the slope of the demand curve. And all I'm going to say is just going to introduce you to it. I'm not even going to explain it. The slope of the demand curve is constant. It doesn't change along a linear, a straight line curve. Okay. However, the rates of change, the percentage changes of price and quantity demanded are not constant. As the price increases, the percentage change in price diminishes, while the percentage change in quantity demanded increases. Therefore, the slope, which is constant, cannot represent the formula for PED, which is the percentage change in quantity demanded over the percentage change in price. I honestly feel that is probably as much attention as should be intelligently given to that question. Okay, now we're on to this. Hello, my dear friend, this question again, okay? The following diagram illustrates the weekly demand for sunglasses in the town of Picton. Okay, that's the demand curve, no problem. The market supply for sunglasses in Picton is given by the equation QS equals minus 450 plus 100p, and where QS is the quantity supplied per week and P is the price per pair of sunglasses in dollars. On the diagram above, plot and label the supply curve for sunglasses in Picton. Right, so, well, I need a bit of space to work here, so I've got another sheet of paper here, and just at the very top, I'm going to write down, just make sure you can see it, and you can, that the quantity supplied equals minus 450 plus 100p. Okay, now, for reasons again that I have said, okay, I am not going to choose P equal or QS equal to 0 because I will get a 4.5 and that there's not a joining of grid lines at 4.5. That would be around there. So what I am going to choose is, the first one I'm going to choose is P equal to 5, okay? Okay, so QS, quantity supplied, equals minus 450 plus 100 times 5. The quantity supplied equals minus 450. 100 times 5 is 500. Okay? Quantity supplied equals 500 minus 450 is 50. So what I'm going to do is I'm going to write over here P equals 5, quantity supplied equals 50. That is one dot. Okay? That is one dot that I can now put on the diagram. Here's 5 and here is 50. Okay. Now, the next thing I'm going to choose is, for no reason other than I know it'll give me a spot where a dot where the grid lines cross, I'm going to choose a price of 10. Okay, so P equals 10. So I have QS equals minus 450 plus 100. Instead of P, what I'm going to write 10. Okay, QS equals minus 450 plus 1000. Okay, QS equals 1000 minus 450 is 550. Okay, no problem there. So I've got a P equals 10, a QS equals 550, and then that's my second dot that I put here. Okay, 550 up to this point here. Okay, now I probably shouldn't have made that dot that big because it reduces the accuracy. All right, yeah. Something along the lines of that. Okay, excellent stuff. So what we have here now is S. Okay, there's the supply curve. Using the diagram, identify the, it's always best if you can see it. Using the diagram, identify the equilibrium price and quantity. Okay, well, what I'm going to do here now is I'm going to go down from the point where they join. Okay. And that looks like 450 to me. And then I'm going to go across from the point, or the equilibrium point. Okay. And that looks like $9. So what I'm going to say is equilibrium price, okay. Price EQ equals $9. And quantity EQ equals, reading it here, I've smudged it, but anyway, 450. Okay, I really hope that that is okay, makes sense, no problem there. Okay, now, the next thing here, it says, state the price at which 50 pairs of sunglasses would be supplied. Okay, so what I'm just going to do here now is I'm going to have a look at this supply curve again, or supply function. QS equals minus 450 plus 100p, but I'm going to set QS equal to 50. Okay, so it's 50 equals minus 450 plus 100p. Bring all the numbers over to one side, so we get 50, bring it over, change its sign, plus 450 equals 100p. So that's 500 equals 100p. Divide both sides by the number before, the letter we're trying to find. 100p divided by 100 simply equals p, and 500 divided by 100 equals $5. Okay, so the answer to this question up the top here is that at a price p equals $5. Okay, simple as. You're just solving for p when you know what the quantity is. Okay. Define the term producer surplus. Producer surplus is the difference between the price the producer receives for selling the good and the price the producer would be willing to sell the good for. And that's the benefit to the producer of operating in the market. Okay. In country of Zestria, the monthly demand for good X is given by the function QD equals 420 minus 30p, where QD is the quantity demanded per month and P is the price per unit in dollars. From the equation, identify the slope of the demand function given above. And again, lads, the slope is the number before P. The quantity demanded is 420 minus 30p, so the slope is 30. No, it's not. It's minus 30. Okay, don't forget that. Okay, you need the sign there. Calculate the price at which the monthly quantity demanded will be 210 units. Okay, well, let's see what we can do here. So we go QD equals 420 minus 30p. Okay, and then so we're going to say QD equals 210. So we're going to go 210 equals 420 minus 30p. I'm going to bring the minus 30 over, so I get 30p equals 420 minus 210. 30p equals 420 minus 210, I believe, is 210. I'm going to divide both sides by 30. And again, 30p divided by 30 is going to give me 1p. Okay, so I'm just going to write my answer up here, p. And then 210 divided by 30, and I believe that that is $7. Okay, so again, all we're just doing, I'm going through my cheat sheets here, all we're just doing is, excellent, I am right, all we're just doing is just working out a bit of algebra. It really, guys, like, you've got this, it's not hard, you've got this. Okay, so again, just going on to another very, very, very similar question. Okay, and just making sure you can see. Okay, so calculate the price at which the monthly quantity demanded would be 260. Okay, well, again, what are we going to write down? So QD equals 420 minus 30p. Okay, no problem. And we're calculating the price, and quantity demanded equals 60 units. So QD equals 60. So here what we're going to write down is 60 equals 420 minus 30p. Okay, I'm going to bring the minus 30 over, minus 30p over, that becomes a plus, and it's going to become 420. Going to bring this plus 60 over, that becomes a minus. So 30p equals 420 minus 60, and that is 360. Okay, 30p divided by 30 is, well, 1p. So I'm just going to write this here, p equals, and then 360 divided by 30, and I believe that's 12. So that's $12. Okay, and that's all we're saying. Like, you really have this. Please don't be stressing. Please don't be concerned. Please don't be worried. Okay, no problem whatsoever. All right, now the first thing here, I've already done it, and I've gone a little bit, overboard, or whatever. Okay, label the axes on the grid. Right, price of good X. Where did I get good X from? It's given in the question already. Okay, the monthly demand for good X is this. All right, so that's the first thing. So price of good X, dollars per unit, quantity of good X demanded per month. All right, to be honest, if you just wrote price there and quantity there, that was enough for full marks. Okay, but why take the chance? All right, why take the chance? So we've labeled it, we've already answered it. Okay, construct the demand curve for good X on the grid. Well, we need to go, okay, so QD equals the 420 minus 30p. Now, demand is usually easier to solve for than supply, and the reason is because it's going to touch both the X and Y axis, both the price and quantity axis, within the top right quadrant, the positive quadrant, okay? So what you can always do here is you can set quantity demanded equals to 0 and solve for price, okay? So I bring the price over, get 30p equals 420, okay? So you bring it over, you change its sign, all right? So what I'm going to do is I'm going to write here 420 divided by 30, and I get 14. Okay, so I obviously divide both sides by the number before the letter we're trying to find. I'm trying to find P. 420 divided by 30 is 14. Now, if I go here, right, and I find my pencil, which is here, at a price of 14, quantity demanded equals 0. So this is 11, 12, 13, 14. Here is one dot, okay? Here's one dot, just so you can see the whole diagram. All right, that's the first thing. Now the next thing here, and I might as well write it out here. So let's move this down so you can see. P equals 14, quantity demanded equals 0. Now the next thing I can do is I can find out, I can set quantity demanded equal to 0. So we've got quantity demanded, okay? Or sorry, I can set, excuse me, silly me, I can set price equal to 0. So that quantity demanded equals 420 minus 30p. And this is the easy one, okay, equals 420 minus 30 times 0. Quantity demanded, 420 minus 0. Quantity demanded equals 420. So that means here now, guys, what I just do is I go 420, 440, 460, 485. So I can go here. And I can just go put a dot there. And now, in order to draw this diagram, all I've got to do is get all my pencils out of my own way and make sure to line it up as best I can. And we have demand like that. Okay, I really, really, really hope that makes sense. Okay, you just need 2 points. We've done this for demand and supply. Okay, you only need 2 points. Okay, now, again, I suppose to finish off on a very important type of question, right? It says, outline why the position of the demand curve in 2C will change. Why would it change? All right, if the demand function changes too. So it was this. I wrote this in extra. QD was equal to 420 minus 30p. And now it's 500. So that means at every single price more is going to be bought. If that happens, you should know from just the theory that that's an outward shift in the demand curve. Okay, outward, rightward, upward, whatever the flip you want to call it, it doesn't matter. So the demand curve will shift to the right by 80 units at each price. So why 80? Because the intercept is bigger by 80. That's why. If it was lower by 100, it would shift to the left by 100 units at each price. That means 100 units less would be bought at every single price. Now, 80 units more are going to be bought at every single price because the quantity demanded has increased by 80 units at each price. Okay, so what it's asking is, what's the effect when the intercept changes? Well, if it gets bigger, it's going to be more is demanded or supplied. If it gets smaller, it's going to be less is demanded or less is supplied. Okay, now outline how the steepness, and we know about the slope, okay, how the steepness of the demand curve in 2C will change if the demand function changes to 420 minus 40p. Okay, now, as we said already, it was 420 minus 30p. So right now what we're saying is the intercept hasn't changed. So the number before p has changed, therefore the slope has changed. And it's gotten bigger. It was it's gotten, the number itself, shall we say, the absolute number has gotten bigger. Just the minus just tells you the direction of the curve, if it's downward sloping or upward sloping. If it's a plus, it's upward sloping. If it's a minus, it's downward sloping. But the absolute value has gotten bigger. And what we're saying is the demand curve will become less steep. It will become flatter or shallower. And why? Because this measures here the change in quantity demanded if price changes by 1 unit. Okay, that's what it measures. Okay, this is because for any change in price, the change in quantity demanded will now be greater. It was only changing by 30. If price went up by €1 or $1, quantity demanded fell by 30. Now it's falling by 40. It's having a bigger change. It's becoming flatter and flatter. Okay, and the reason is because for any change in price, the change in quantity demanded will be greater, and hence the curve will be flatter. Okay, that's every single question. And that video on market equilibrium, and that video now represents the end of section 1.1, unit 1.1, for paper 3 stuff. Okay, and I really hope that that makes sense. I'm just getting all my papers together here, forgive me. So this market equilibrium question, this market equilibrium problem set, is the last in 4 problem sets, which should cover you for unit 1.1, competitive markets, demand and supply, for HL paper 3. Okay, I really hope they help. And just, guys, the only way to get better is to keep on studying. Thanks very much.